In this video, we'll take a first look at a guitar pedal circuit and prepare for a breakdown of this circuit. In today's session, we'll keep things relatively simple and light as a nice introduction. So the first circuit we'll be looking at is the LPB1 guitar pedal by Electro-Harmonix. The LPB1 is a very simple boost circuit, utilising just a few components to accomplish this boost effect. Here's a look at the schematic for this circuit. As you can see, there isn't a great deal going on here and is a great circuit to get started with. In the coming weeks, we'll thoroughly break down and understand each section. The posh name for this circuit is a common emitter amplifier with voltage divider bias. This may mean nothing to you currently, but hopefully will in the coming weeks. This is a topology found in numerous other guitar pedal circuits, including the output of the Big Muff pedal. So there's a few self-explanatory labels in this schematic that help dictate the signal flow within the circuit. We'll talk first about the power supply within this pedal. So as you can see, this is labelled as 9 volts. The 9 volt power found in a guitar pedal is courtesy of your power supply or 9 volt battery. This 9 volt power supply is a DC voltage. You will always see a DC voltage when dealing with a power supply as providing power for electrical components to operate. So this line coming from the 9 volts is known as the power rail. There are a couple of utility components that we'll deal with first. Now these components aren't in the original LPB1 circuit, however they are important additions found in all modern remakes and pedal designs. The first one is the reverse polarity protection diode. This diode protects the components in the circuit if a power supply with the wrong polarity is plugged into the pedal. When this occurs, the diode will turn on, diverting the signal through the diode to ground, preventing any of these dangerous voltages from travelling to the components within the circuit. Hopefully, this diode never needs to be used, however it's a very good idea to have it within your circuit just in case. The next component is the electrolytic capacitor seen next to the diode. This is a filter capacitor, helping to smooth out the power supply and present a clean power heading to the relevant components. An unfiltered power supply can present noise interfering with the performance of your pedal. So again, this is a good component to utilise. Ultimately, the power rail is utilised to supply the transistor with the voltage it needs to operate. The transistor is the focal point of this circuit and is the device responsible for the amplification. Voltages are being fed to both the base terminal and the collector terminal of the transistor via the relevant resistors. We'll cover in detail the implications and factors of this in the coming weeks. For now, we'll just accept that it needs voltages in these locations to operate accordingly. Now we know the transistor is being provided with the voltage it requires, we can take a look at the signal path of the signal generated at the guitar pickups. Unlike the voltage found at the power supply rail, that voltage at the input is an AC voltage. This AC voltage travels towards the base terminal of the transistor, where it is then amplified by the transistor, leaving the collector terminal at a much larger amplitude. An important consideration to take into account is the signal leaving the collector will be inverted. I've used this graphical representation to show the scope of the amplification process. The blue line is representative of a 200 mV AC voltage signal generated by your guitar pickups. The green line is the signal from the collector of the transistor. As you can see, it is both larger in amplitude and is indeed inverted. In the coming weeks, we'll take a look at how to calculate the impedance values of the circuit, as well as the gain and bias points of the transistor. However, in the next video, we'll take a look at the components located at the circuit's input, what they do, and the implications they have. Hope to see you there.